So we have now done 2 by 2 matrices by the formula, 3 by 3 matrices by expanding along a row or column. What about higher sizes, bigger sizes, like 4 by 4? So here's a 4 by 4, and the principle is exactly the same. So we use either a row or a column and work with the entries and their cofactors. So let me explain here using, I make a choice here, I'll explain perhaps later what choice I'm going to do. I'm going to do here row 1. So this is row 1. That means I'm going to use this row. Now, so what this means? The first element here, that is in the first row in the first column. Remember, that is how we denote these entries. And the corresponding cofactor, of course, has the same indices. Plus. Now, this element is still in the first row, but in the second column. This is the row, this is the column. All right? So, and the cofactor is the same, plus this element is A13, C13, and then finally the last element is A14, C14. Again, row, first row, fourth column. Okay. Now, if you notice that actually, so let's write the values. A11 is 1, A12 is 0, A13, I'm talking about these numbers, right? A13 is equal to 0, and A14 is equal to 2. So we see that actually these two already cancel. We don't need to calculate them because 0 times whatever is 0. And that's exactly why I chose row 1. Then, because it has many zeros in it. And each time you have a 0, things become much simpler. So what we have to calculate is C11 and C14. Okay, let's start doing that. Now, we have to also be careful because at the same time we have a sign pattern, plus, minus, plus, minus. It's like a chessboard or whatever you call it. So here is checkers. Here we have to alternate pluses and minuses. Minus, plus, minus, plus. A11 corresponds to a plus. So C11 is plus, I'll just write it for emphasis here, plus, and then the determinant. What is the determinant now? Well, we do the same principle as before. To calculate the cofactor, to calculate this guy, we just scratch out the row and column of this guy. So this would be scratch out this and scratch out that. Okay, so this is, therefore we have the matrix, the determinant we have to calculate is this one. So that is 4, 0, minus 1, 2, 1, 2, 1, 0, 0. So one more time, it's because I delete this row and I delete this column, and that is what's left. Okay. Okay, so let's continue calculating this here. We see now that we can again choose which row or column that we use, and I'm going to make a smart choice here. I'm going to take row 3. So I'm going to row 3. So notice that I always write here on top what row I use. Why do I use row 3? Well, exactly because of the zeros again. I have to now use these 3 elements in the formula, but there's only one that matters, that is this one. Okay, so, so this means this element is a 1. What's the sign? Remember, there's always a question about the sign here. And well, to find the sign, we have to look at the pattern for 3 by 3. So I'll do that here. Plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay. You can also, for instance, just superimpose the pattern onto your determinant. So you can say plus, minus, plus. Okay. All right. So this is a plus sign. So therefore I'm not gonna write. Yeah. Let me emphasize it with a plus here. So this plus is from this plus. Okay. And what's left? Well, simply by what we know now is we scratch out the row and column, and what we are left is 0, minus 1, 1, 2. And that we've solved by the formula. 1 is nothing, so there's 0 times 2, that's just 0, minus, and then this product is minus 1. So minus 1, that is 1. Okay, so this takes care of C11. Let's do C14. C14. What is C14? Well, it's a determinant. sorry, let me move this a little bit down. So C14 is a determinant, but there's also a sign involved. So let's think about the sign first. The sign comes from C14 is dealing with this element here, right? This is the C14, or this is A14 and the corresponding cofactor. This is A14, the corresponding cofactor is C14. This in the pattern corresponds to a negative sign, so we get a negative here. So this negative is that negative. Okay? How do we calculate now? What is the determinant? Well, it's as before. Since we are dealing with 2 here, we scratch out this column and this row, and what we are left with is 3, 4, 0, 0, 2, 1, 1, 1, 0. Okay. I'm going to make again a good choice by choosing something that has many zeros in it, and if you look at it, can you see it? Right? So the choice I'm going to make is this one here. So this is actually column 3. In column 3, there's only one element I have to deal with, and so this is the element and then its corresponding cofactor. The other 2 terms I have are 0 because of these zeros. All right, what's the sign? Okay, we can do plus, minus, but if you look at the sign pattern here, that's what we're doing. Let me do it in a different color, then you see better what I'm doing. So this one here corresponds to this negative sign, so we have a negative here. Now, don't forget we have already a negative, right? So we have 2 negatives here. So this negative is from there, this is the negative that we already had. So I'm going to write -1, and then what is left? Well, as always, we scratch out, and we find 3, 4, 1, 1, right? And that is, so minus becomes a 1. No, sorry, that's not so this is just 1, we don't rewrite it, so this is 3 minus this is 4, so -1. All right, so our determinant, the determinant of our matrix is A11, 1 times C11, which was 1, plus A14, which was 2, plus, sorry, not plus, minus, times, of course, times -1, that's the C14, so we have 1 minus 2, that is -1. So that's our determinant, -1. Well, let's verify it. So the whole idea is that we make choices, but it doesn't matter which choice we make. And so just to see this, let's do it in a different way, and in fact, let's try to do it in a smarter way. So here is the matrix again, determinant again. I'm not going to choose not something with as many zeros as possible, and there's a very good choice. I hope everybody sees it. If not, pause the movie and look at it till you figure it out. And what it is of course column 3. So I'm going to do column 3 expansion. Okay. There's only one term that we have to deal with, that is this guy. So we have the 1 here, that's the element, and then here we will have the minor, but there's also the question of a sign here. What's the sign? Well, again, we look at our pattern, at the plus-minus pattern, as you can see here. We are talking about this element, which is a plus sign. Or, as I said, you can do superimpose this on your thing, right? So this is a plus, minus, plus, minus, plus. But it gets, the more you write in this thing, the harder it is to misread things. So be careful with that. Okay. So it's a plus sign. The 1 is this one. And then finally, we are left with, well, again, we scratch out. We have 1, 0, 2, 3, 4, -1, 1, 1, 0. This time I am not as lucky. I don't have rows with many zeros, but at least there are some columns and rows with 1, 0. I'm going to pick one. The most obvious one is this one, the row 1. So I'm going to expand row 1. We have a plus. We don't have to care. +1, that doesn't matter here anymore. So we're going to use these 2 elements, okay? This element, now remember, I'll make the little plus-minus pattern again for 3 by 3. This looks like this. So we're going to have a plus here for the 1, and also, by the way, a plus for the 2, okay? Because, and the 0 should come with the minus sign, but of course that doesn't count. So we have 1 times what is left, okay? We scratch out the row and column in which this element lies, and we see that is left, I'm gonna 4 minus 1, 1, 0, right? 4 minus 1, 1, 0, plus, now remember, because we have to do every element in this row, and there are 2 of them that are not 0, so now we have to, the contribution of this one is 2 times what is left. Well, this time we scratch out 2, and we are left 3, 4, 1, 1. And it's a plus sign, I repeat, because we have a plus here, okay? Now everything, these 2 things here, we can calculate just by the formula. We get, well, 1 is 1, so don't write that. 4 times 0 is 0, and then we get minus this product, minus 1. Be careful, right? The formula is AD minus BC. Don't forget that there is a minus sign here. So that is the determinant of this 2 by 2 matrix, the first one, plus 2 times, and what is the other one? This times that is 3, minus that times that is 4. So we get minus minus is 1, plus 2 times minus 1, and this 1 minus 2 is again negative 1. And we see we get the same answer. Okay? And sometimes we can be really lucky that here we had to do a little bit more operations, but let me give an example where you can even be smarter, and I think there will be also a homework problem like that. So here is an example from the book. Let me go back blank. We take this matrix 1, 0, 0, minus 1, 3, 1, 2, 2, 1, 0, negative 2, 1, 2, 0, 0, 1. Okay, so pause the video and try to solve this by choosing very smartly your rows and columns each time you have to calculate a determinant. Okay, I'm going to go on. So I noticed that the best way to do it is to use this column. It's the only column or row that has so many zeros in it. So I'm going to use column 2. This means that I have only one element to take care of, this one. Okay, what's the sign? Well, if you do the superimposition, you see that the sign is plus. If you don't see it, let me copy the signs again. Plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus, plus. We are talking about this element, that's a plus sign. So we have a plus, just to emphasize this here, 1, that's this element, times, and what's the matrix left? Since there's only element, I don't care now, I can scratch this out. What is left is 1, 0, minus 1, 1, minus 2, 1, 2, 0, 1. Okay, we have now a 3 by 3, we do the same thing, but again, there's a good choice. If you pause the video if you don't see it right away, but perhaps you see it right away, it is this one. So I'm going to now use column. The calculation for this one is now again column 2. Okay. So in a 3 by 3, the pattern is plus, minus, plus, minus, plus, minus, plus, minus, plus, which in this case, so we're going to use this element, which corresponds again to a plus. So we get plus negative 2 times, and what is left? Well, we scratch out. We have 1 minus 1, 2, 1. Right? Yes. Then is what's left. So I get minus 2 times 1 minus minus 2. That is 2 times 3, that is 6. And no, sorry, I copied it wrong, right? It's minus 2 here. Where did my minus go? Minus 2. So the answer is minus 6. Sorry about that. It's minus 6. Yeah, this is very, very easy to make mistakes with minus signs. Really, you have to really keep track and double check each time that you didn't forget a minus sign or that you cancelled out the minus signs properly. Okay, I want to discuss 2 more things very quickly. a case where you can always use this method by choosing a very good column and row is by upper triangular matrices and lower triangular matrices. That's one of the reasons why we would like to study them. So just a simple example, suppose we have the matrix 4, 3, 0, 1, 0, 0, 1, 3, 0, 0, 2, 1, 0, 0, 4. Sorry, this has to be a 0 here. 0, 5. This is an upper triangular matrix because underneath the diagonal we have all zeros. Okay, that's the reason. So it's upper triangular. Upper triangular matrix. That's from the previous chapter, right? That we discussed this. Okay, so in an upper triangular matrix you can do very systematically. You start with the first column, column 1. This column, because it has only one element in it, by the virtue of that it's an upper triangular matrix. Okay, so this is equal. And also, what are the signs? Well, if you look at the sign patterns here, notice that on the diagonal you always get pluses, no matter what pattern, what size. If you don't believe me, try other size. It always comes out pluses here. So since we are gonna, you will see, we are gonna only deal with this diagonal element, so we only have to have pluses here. That's another simplification. So we have 4 with a plus sign, as we already said, and what is left? Well, we scratch out this and we scratch out that. Now, since this was an upper triangular matrix, these guys are 0, and therefore this again is an upper triangular matrix. If you don't believe it, well, here it is. 0, 2, 1, 0, 0, 5. Right? Here are the 3 zeros underneath the diagonal, which makes it again upper triangular. So this is also upper triangular, a 3 by 3 now. And we keep doing the same thing. We look at the first column. Now, in this case, we are even more lucky because everything is 0. So if everything is 0, well, then there is no contribution anymore. If you expand, so if you expand along column 1, then you get just 0. This 4 doesn't matter anymore because it's 0 times whatever, 0 times whatever, 0 times whatever. If you take this, if you go along this row. Okay? What does this mean now? Well, I'll do a second example and then we can actually formulate a general result. I'll take the same matrix except I'll change it slightly. Instead of putting a 0 here, let's put a 1 here. 1, 3, 0, 0, 2, 1, 0, 0, 5, 0, 5. So this is a different matrix, eh? New matrix. I just chose that. It's not exactly the same, it's almost the same. Okay, so we follow the same principle. We're gonna go by column 1 because it's an upper triangular, column 1, and we get a 4, the element, times what is left. Well, sketch out. We get 1, 1, 3, 0, 2, 1, 0, 0, 5. By now, you should be able to finish this problem. So I would really encourage you to stop the movie, do it yourself, and then check the answer. But I'm gonna go on. So I now use again column 1 in this 3 by 3 matrix. So I'm going to use this column again. So I have 4, this 4, times this 1, times what is left. Well, sketch out, and I get a 2, 1, 0, 5. And no surprise, this is again an upper triangle matrix because of the 0 here. Here's a triangle. Okay, which we could do by the formula, but let's do now actually keep going. Let's do column 1 again. So we have 4 times 1, I'm just copying. And now what we have, this column here, we have a 2. Remember, it's always, see, we actually always use the upper element here, which we know has a plus sign, right? Here, these guys, the top element always starts with a plus. So we don't have to think about signs here. All right, so we do this. We have 2 here. And what is left? Well, sketch out. We have only one number left. Of course, the determinant of a number is just the number itself, viewed as a 1 by 1 matrix. So we just get 5. And so the whole thing is equal to 40. What are these numbers? Well, no surprise. Look at them, where they come from. They are exactly the diagonal elements. And so what this means is that the determinant of an upper triangle matrix is just the product of the diagonal elements. That's very simple, which is not at all, if you look at the examples that we did, the case for arbitrary matrices. And therefore, like look at the previous example, the diagonal elements were 4, 0, 2, 5, and the product, of course, is 0 because of the 0 there. Okay? One more homework problem that you're going to run into is the following question. Find A such that the matrix 1, A, 0, 0, 0, 2, 1, 1, A is equal to 0. Okay, let's see whether we can figure this out. So now the question is a bit different, right? It says find A, so A is going to be a number, such that this becomes 0. Okay, well, let's write down the formula for this. So when is this 0? Well, let's write down the formula. And I'm going to do expansion. Any guess what I should do? Again, pause the matrix, the movie if you don't know what to do, what it would be. But there's an obvious guess here, namely the one that has most zeros. This one. So I'm going to do, this is row 2. Okay, so we have this 2 here. What's the sign? So what is here? Question mark, okay. Well, we look at the pattern. It's a plus, minus, plus, minus, plus, minus, plus, minus, plus pattern. We are talking about this guy, negative. Times what's left? Well, we scratch out whatever it is that we had, and we see what is left is 1A, 1, 1. This is a 2 by 2 matrix, we can work out right away. It's the product of the diagonal elements, that is 1, minus the product of the two other ones, that is A. So we get minus 2 plus 2A. Well, actually, it's better not to expand this, because remember the question was actually when is this 0? And the product is 0 if one that this, of course, can never be 0, so this is clear that this is 0 if A is 1. Okay, so that's a homework problem that you will see. Okay, so the homeworks, as assigned, the homeworks are for 2.1. And as I explained, you can show me either all the homeworks you've done by sending me a picture of your homework solutions, but it's enough. I strongly encourage you to do all that, but in case it's too much, I want to see at least 2 problems. So the special problems that I need to see, at least see you try to do it if you get stuck, but I have to see you have done some of these things. I want you to do number 17, and I want you to use this is sorry, I'm trying to find it here. Give me a sec. Okay. Number 21. But don't just do these 2, do all the problems. But you have to show me at least these 2. They are not so hard. There's another method that is described in the textbook, which is called the arrow technique to calculate the determinants, but I'm not covering that. We will find in the next chapter, in the next section, we'll do a method using row reductions, which for us will be the main method, or this method that we just described. All right, that's it.